Hello, our group is Remote Smart Meter Disconnect Delay. Our project's goal is to create a smart meter with a hardware random time delay to improve cybersecurity and prevent grid failures. If an attacker hacked into and disconnected many smart meters, it could cause a frequency shift in the power grid. Generators are sensitive to frequency changes and will shut down if the change is too high for too long. The North American Electric Reliability Corporation, NERC for short, defines a minimum frequency change before generators can shut down. For example, the Texas grid, shown in red, requires an instantaneous frequency of over 61.8 Hz and a continuous frequency of 60.6 Hz before generators can trip offline. We reached out to the Power IT Lab at the University of Tennessee, Knoxville to run a power grid simulation. We chose the Texas interconnection due to its susceptibility to load loss. A simulation with 2.3 gigawatt load loss raised the continuous frequency above 60.6 Hz, enough to trip generators after 9 minutes. A larger load loss of 4.2 gigawatts would be enough to trip generators instantaneously. These events would represent losing the load of a large city. We designed a model to demonstrate how to mitigate this problem. Here's a circuit diagram of our design. We're using 120 volts from an outlet as a power source. Our model is protected by a GFCI and fuse. The power runs through the smart meter, which measures power consumption. That power consumption comes from a 150 watt load resistor and a 60 watt lamp. The relay disconnects the load when it receives a signal from the microcontroller. This microcontroller is programmed to send a signal to the relay coil after a random time delay. The time delay is displayed for demonstration purposes. The other microcontroller is within a handheld remote powered by a 9-volt battery. This remote features an on-off switch and a push button to tell the microcontroller to send the disconnect signal wirelessly. Over the last few weeks, we started buying parts needed for our model. This GFCI and fuse protect the circuit. Power runs into the smart meter enclosure and powers the microcontroller. The smart meter measures the power flow. This resistor will act as part of our load. A lamp will be added later. This is the relay that will disconnect the power. This microcontroller will be programmed to initiate a random time delay and operate the relay. The second microcontroller is housed in this handheld remote control that we've already assembled.